Hey everyone, so basically in today's GFG POTD we have a problem identical linked list. So basically it is a basic level of problem, and here as the problem given here, given two singly linked lists respectively, the task is to check whether two linked lists are identical or not. Two linked lists are identical when they have the same data and with the same arrangement too. If both linked lists are identical, then return true, otherwise return false. So basically in this problem, we have like two linked lists, basically two lists, and we need to check whether whether the linked lists have like the same data and with the same arrangement. Okay, like we are saying that if the linked lists are having if both the linked lists are having like same data and the same arrangement too, then we can say that the given like arrangement of data of linked lists are like we can say it identical linked lists. So if we are taking an example here, so if I'm going through first example, so as it is given here, in the linked list 1 we have like the elements 1 2 3 4 5 6, and the linked list 2 contains like 99 59 42 20. So by looking at this example, we can directly say that the given linked lists are not identical. Why? Because we can say here that the elements from both the linked lists are actually not equals, and also the arrangements are also not equals. Okay, like it has having like 6 elements, and also it is having like 4 elements. So these are like lots of difference, so it is like not identical. But if you're talking about the example second, then we can say here that like this second linked list, this second examples are having like 1 2 3 4 5 element in the linked list first, and also in the example and also in the linked list second, it is having the elements like 1 2 3 4 5. So here we can say that the arrangement of the both the linked lists are actually similar, and also the elements are also equal in both the linked lists. So we can say that this example is actually identical, or we can say that this linked list is identical. So here we need to solve this problem with an expected time complexity of order of n and expected average space of order of 1. So the topic text for this problem is like linked list, data structures, and algorithm. So basically in this problem, if I have to explain about how we can solve this problem, so we know very well, like if I'm going about like example second here, so as we have discussed here, like in example second we have elements like 1 2 3 4 and 5, and also in the second linked list we have elements like 1 2 3 4 5. So by looking at both this linked list, we can say that these are considered to be identical, as the elements are also equals in both the linked list, and also the arrangement is also equal, right? So how we can solve this problem? So for solving this problem, first of all we need to traverse through complete linked list. So for traversing, we are actually using like a while loop, and inside while loop we are actually creating like temp variable which basically stores the head node. We know very well about head node or head pointer. Head pointers are basically arranged at the first element of the linked list node, which basically defines that this is the first node where the linked list is going to be start. So as I'm saying here, this is my like head 1 and this is my like head 2 for both the linked lists. So if I'm saying that this is my head 1 and which one to okay, so this is my head 1 and this is my head 2. This head 1 is actually defines the first node for this linked list 1, okay, and this head 2 basically defines the linked list node for this linked list 2, okay. So we need to traverse in both the linked list simultaneously, and we need to check for all the elements that whether they are equal, and also we need to check whether the arrangement is actually like arranged in the proper manner or not. If it is like in the proper manner, then we can say that it is identical. If both are actually arranged in the proper manner also, and also elements are actually equals, then we can say that it is identical. So for traversing, we need to store some temporary variable which basically stores the head variable, window variable. For traversing inside the linked list, we are actually getting the temp variable where we have to store the head node, and window traverse the complete linked list by using temp variable. So let's solve this problem first. So here I'm saying that first of all we have to create a temp. This temp must be like created by using node star temp as I'm signifying for the first linked list. So I'm saying here temp1, which is equal to, like, I'm storing the head 1, that means the first node the first node I'm storing inside the temp1. Okay, so yeah, similarly for the node second or the linked list second, we can say that temp2, I need to store the head 2, which is actually defined here. Okay, head 2. Now once we have created like temp1 and temp2 temporary variable, we need to traverse it. So for traversing, I can say that here while temp1 is not equal to null, and that means logical and temp2 is not equal to null, so we need to traverse. Here this lines means we need to traverse complete linked list. We need to traverse through complete linked list until our linked list is not becoming null. Okay, I need to do for all. That's why I'm using here logical and. That means both. I need to perform this action for both the linked list, and inside this I need to check whether the elements of the linked list are like equal or not, or whether they are actually following the proper element or not. So for that I'm saying here if temp1, which basically signifies for the my first linked list, temp1's data is like, if I'm saying it is like not equal to like temp2's data, temp2 data, then I can simply say that return false, because if both the if like datas are not equal, then we can simply return false, right? Because we are actually searching for the identical element. Okay, and this process I've done for the like first process. Now I need to move forward my temp node. That means temp1 is equal to temp1 next. Similarly, I have to also move my temp2's node to next node. After having all those things, we need to come out from this loop and saying that, like, if this process is actually happening, like if I'm talking about if this is actually happening, and if it's like not equal, we need to simply return false, and if it is like equal to, then we need to simply return true, right? That's why I'm saying here like this thing. But before that, before saying that the linked lists are identical, we need to also check the numbers or the alignment of the linked list. So for that I'm saying here like that if temp1 is not equal to null, or temp2 is not equal to null, that means either temp1 is going to be equal, is going to be null, or temp2 is going to be null. So for that thing we need to check, we need to simply return false, else return true, else we have to simply return true. Now let's try to compile and run. So it's executed. Now let's try to submit it. So it's correct and it's also submitted. So basically this line signifies that actually we are checking for the numbers of the elements, that whether they are having equal or not. Like for example, I am saying here, like I've created here extra nodes for explaining purpose. So let's suppose if I'm saying here like this, like I've created this node and I'm saying that, like I'm saying 6 and 2. Now as I can say here, now this time this both the linked lists are like not identical, as it contains like 7 element and 7 nodes, and also this contains like 5 nodes, and the elements are actually not equal. So for till here it is like equal, so here we can say that it is equal. But from this code I'm saying here, from this code, if temp1 is not equal to null, or like temp2 is not equal to null, that here I'm saying that if temp1 is like not equal to null, either temp1 is not equal to null or temp2 is not equal to null, or like both is equal to null. That's why I'm saying here logical or we need to simply return false, else we need to simply return true. That means if it fails to satisfy this condition, then we need to simply return true. That means till here, if we are actually achieving from this position, and if this code is actually fails for this condition, we need to simply return true. So that's what I've written here. So yeah, that's all for the today. Thanks for watching.